In this video, we're going to have a look at solving exponential equations. Now, something that you might have noticed is that this looks similar to a quadratic, but not completely like a quadratic yet. And to make it look even more like a quadratic, well, actually, even before that, there's a step that we can do. So this middle term, 15e to the minus y, well, e to the minus y, it can be written as 1 over e to the y. So we can write this out as 15 times 1 over e to the y. We're going to write out this equation using that format, and I'll tell you why as soon as we just do it right now. Perfect. Now, if you multiply each individual term by e to the y, what you'll see is, well, first of all, e to the y times e to the y. A lot of students get confused with this. Whenever the base is the same and you're multiplying indices, you just add the powers together. In this case, y plus y is 2y, so this will become e to the power of 2y. So that means the first term overall will just become 2e to the 2y. The e to the y in the denominator will cancel out with this that you'll add to the numerator, so you'll be left with just plus 15 for that second term, and it's equal to 11e to the y. Remember to also multiply to the right hand side. If you then subtract 11e to the y from both sides, you'll be left with 2e to the 2y. I'm just going to squeeze this in the middle of the two terms, and I'll show you why. Once I've done that, this looks a lot more like a quadratic now, doesn't it? This is what we call a hidden quadratic. You can actually make it so that it looks even more like a quadratic by replacing e to the y with a singular letter. Let's say let x equals e to the y. Once it's in this form, you just want to replace the middle term with a singular letter. After you do that, like I said before, e to the y multiplied by itself, or in this case x squared, can represent e to the y. That means that this whole first expression can be written out as 2x squared minus 11x plus 15 equals 0. If you're able to solve it from a quadratic format from here, you can completely do that. But some students like to make it in terms of x's or y's, so I've just done that here. And then you can use whatever method you use to factorize where there's a number before the x squared or a coefficient of x squared. In this case, I use the AC method, so 2 times 15 is 30. Two numbers that multiply to give positive 30 but add to give minus 11 are minus 6 and minus 5. I put that in a bracket with 2x, each of those by the way. The reason I put 2x in the beginning of each bracket is because there's a 2 before the x squared. I put one factor in one bracket and the other factor in the other bracket. I just sped through that, but if you'd like me to make a breakdown video of that, just let me know. Now you just simplify each individual bracket. So here, this first bracket, everything's divisible by 2, so let's divide everything by 2. This second bracket, you can't really divide by anything, so we just leave it as it is. Now the first bracket equals 0 when x equals 3, and the second bracket equals 0 when x equals 5 over 2. So those are your two solutions for x. Once you've got those two solutions, do remember that we introduced x as e to the y just earlier on. We don't want solutions to x, we want solutions to e to the y. Once you've got those solutions for x, we're going to replace it with e to the y. And we can say that e to the y can either equal 3 or it can equal 5 over 2. A little trick to get y from here, you just apply ln to both sides. When you apply ln, what happens is there's a rule that you can bring the power forward as a coefficient. So this becomes y ln e, and y ln e is just equal to, well, y, because ln e is equal to 1. Now, because I applied ln to the left hand side, I also applied to the right hand side, and so you get the right hand side becomes ln 3. In a similar way, y here would just become ln of 5 over 2. You do have to be careful here because the inside of a logarithm, it can't ever be negative. So if you do end up with a negative inside the logarithm, you don't count that as a valid solution. But for this question, these are the only two solutions. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website www.excellineducation.co.uk. It's on the first link in the description too.